Not again. OBS is doing this again. It's connecting and I think it's gonna disconnect in just a couple of seconds again. Is that gonna be the case? Works for a short while. Or... well, let's see if it disconnects again. Two pages. 3 pages of message today. So not too much text. Alright, hello everyone. It is today 16th of December, weekend Saturday. So I actually have high expectations for today's puzzle that it might get quite involved, but we'll see in a moment. Okay, so what do we have? Day 16, the floor will be lava. With the beam of light completely focused somewhere, the reindeer leads you deeper still into the lava production facility. At some point you realize that the steel facility walls have been replaced with cave, and the doorways are just cave, and the floor is cave, and you're pretty sure this is actually just a giant cave. Alright. Finally, as you approach what must be the heart of the mountain, you see a bright light in a cavern up ahead. There you discover that the beam of light you so carefully focused is emerging from the cavern wall closest to the facility and pouring all of its energy into a contraption on the opposite side. Upon closer inspection, the contraption appears to be a flat, two-dimensional square grid containing empty space, that's period, mirrors, that's a /, and that's a British pound. The mirrors are / and British pound. I think this is supposed to be a backslash, but Petsky doesn't have a backslash. So this gets converted pretty much arbitrarily. So / and likely backslash. And splitters, pipe and minus. Yeah, this is definitely backslash. The contraption is aligned so that most of the beam bounces around the grid. But each tile on the grid converts some of the beam's light into heat to melt the rock in the cavern. Okay. You know the layout of the contraption you're puzzling, but for example... okay, so here are the British pounds. So, a backslash here, and backslash here, and so forth. The beam enters in the top left corner from the left and heading to the right. Then its behavior depends on what it encounters as it moves. If the beam encounters an empty space... yep. If the beam encounters mirror, the beam is reflected 90 degrees depending on the angle of the mirror. For instance, a rightward moving beam encounters a / mirror would continue upward in the mirror's column. Okay. So it's gonna go, yeah, just like you'd expect. Come from here, there's a /, it's gonna go like that. Or if you come from here, it's gonna go to the left. And then the same thing for this one, okay? If the beam encounters a pointy end of a splitter, pipe or minus, the beam passes through the splitter as if the splitter were empty space. Okay, so if it's like this, and we come in from here, or like that. For instance, a rightward moving beam that encounters a minus splitter would continue the same direction. If the beam encounters the flat side of a splitter, The beam is split into two beams going in each of the two directions. The splitter is pointing and pointing. Okay, so coming in from here, we continue like these three ways, or two ways. Yeah. Beams do not interact with other beams. A tile can have many beams passing through through it at the same time. A tile is energized if that tile has at least one beam pass through it, reflect in it, or split in it. In the above example, here's how the beam of light bounces around the contraption. So it starts at the top left here, then that's a splitter, so it goes here and then goes here, then reaches the splitter, it goes here, and then here, here. What is that 2? There's a 2. There's a number 2 here. Well, it goes here, and here, and here, 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 and then here. I don't understand. Okay, so it goes something like that. Beams are only shown on empty tiles. Arrows indicate the direction of the beams. Okay. If a tile contains beams moving in multiple directions, the number of distinct directions shown is... Oh, that's why, why there was a 2. Okay. Here's the same diagram, but instead of only showing whether the tile is energized or not. Okay, so it looks about the same. Ultimately, in this example, 46 tiles become energized. The light isn't energizing enough tiles, enough tiles to produce lava. To debug the contraption, you need to start by analyzing the current situation. With the beam starting in the top left, heading right, how many tiles end up being energized? Okay, another simulation puzzle. Yeah, this should hopefully be not much of a challenge, at least in the first part. So let's get cracking. The characters might be a little bit of a trouble. So here's the puzzle input. Let's save this. Save 9 2023 example 16 here. So I need to figure out these characters. What those are. I mean, yeah. And then Shift I, save the device 9, 23 in 16.txt. Okay, so given that I'm doing a 2D simulation where I'm again walking these maps, I need to get sentinel values in the array. I don't want to be checking for x smaller than 0, y smaller than 0. So because I'm doing sentinels, I'm gonna be reading this line by line, so that I can get those sentinels lined up properly. So let's go about it the usual way. And then and now I'm also thinking maybe I should immediately so I have one map that is the input. Then I have a second map that where I'm gonna be building where this light is going to be moving. So I can see here in this example that the light goes into a cycle. So here's the vertical splitter. Oh. Let me put this in here. So there was a vertical splitter immediately in here. So when the light comes in here, it goes down. Then it does this cycle, or how did it go? And it comes here again, and it again splits vertically, so it goes into a cycle. So I need to store the state so that I don't simulate. Like I can stop when I reach a path that has already been traversed. So I need to store that. And that means that I need to store for every cell, I need to store whether there's a vertical or a horizontal light. So that I know exactly like which way I've simulated before. So that means I need 2 bits per cell. So now I'm thinking whether I should well, maybe I can use it for, like, I can use 2 separate maps. It's not gonna matter that much. Let's see. Okay. U8 map. 20,000 map. 20,000. And or actually not U8, but let's do char. And then char destination equals map plus again I'm simulating, so I do need to actually before I do any of that, while f gets map size of map from f, let me again check what the dimensions actually are. Width 0, height 0. Width equals max width in this way. Okay, a lot of typos this morning. So let's just figure out what the size is. The size of the example is 11 by 10. Yep, that's correct. Yeah, and that width includes the new line, so that's correct. So let's see what the size of the actual input is. $110 by $110. Okay, so I can fit it in $128 by $128. So I can do the thing I did the other day. So this is gonna be 16 kilobytes. But I could condense this. Like I could shade bits out of this if necessary. So now I can do char star d equals map plus. So I'm going to advance one row and then one column. And let me define the stride of the map to be 128. What? Well, that's a new one. Overflow error. Okay, so this program has now clearly either returned to basic or called into basic business. Overflow error comes like that must come from basic. That's the only way that kind of thing. But yeah, curious that it's continuously printing. How did I do that? How did I do that? And then there was some. Immediately when that happened, there was some kind of audio beep happen on my PC. I have no idea what happened there. Let's see, do we even have the document left? 2023 16A CPP. Okay, it is there. So let's hope that was just like a random thing. And it doesn't repeat. What am I doing? D, I have the char star D equals map plus S plus 1. So to D stride. So what did I do when it crashed? I think I deleted the line. I tapped Ctrl K on this line, I think. No, I was here and I pressed enter. Yeah, I tapped Ctrl K to delete that line and my cursor was at the very end like this. And I tapped enter here. Yeah. So is it when I am... Is it when my cursor is like at the far end of a line, my editor crashes? I think that might be it. So if if the cursor is outside of the line, yeah, I'm getting an idea of where the issue is. So what must be happening in this case if I go here and then Control K? So now I can have like the end of the line is gonna be at that ++H semicolon. And if I now do enter, it's probably gonna insert in the wrong position. But if I do enter here, yeah, then it works. Okay. Oh, that was a nice one. Interesting that I haven't hit that issue before. But okay, now we know what that crash is and I know how to fix it. Width equals string length of map plus s plus 1 minus 1. Okay, so this should be parsing the map. By 10, yes. So let's do another map of the same size. Why not? The C64 has so much memory. So this is now 32 kilobytes in total. I want this right tightly there. You can go here. And you can go here. Well, okay, whatever. Yeah, I can move this from here. Okay, no, that's a nice start. So, but actually this needs to be global. Because I need a... So I'm going to recurse here. Simulate... Let's try implementing this linearly immediately. So I'm using like one-dimensional linear positions like I did on some of the solutions from earlier days. So I'm not going to have X and Y coordinates. So just position and then I'd like to do just like S8 direction, but this wouldn't work because going up would be minus 128 and going down would be plus 28 and so this needs to be S16. Oh, I don't have a type depth for that, so let's just do into direction. And I also need let me do mask. This is a I don't know what to name this. Shape mask or something like that. So my simulation would start simulate position is 0. No, S plus 1. That's the top left corner. Then direction equals right. And then shape mask. So I would have this kind of shape mask that is like define left to right is bit 1 and define up down is bit 2. So I'm filling the bits of individual bits of this array. And this one is going to the left right direction. So what I would be doing is light position or equals mask. Yeah. Expected. Oh no. My pipe character is now shit. Okay, I've introduced a bug. I was fixing this encoding stuff, but looks like I've broken some of the encoding. Okay, that's gonna be a band-aid. So I was fixing my pipe encoding the other day, but looks like I botched something up from here. So I need to use that one. And initially, actually, if light pause and mask return. So if this direction actually has already been simulated. Then I don't need to do it again. Yeah, and here pause plus equals direction. But not okay, so now I need to look at the if not map pause. So if I'm in the sentinel valley, if I'm out of bounds. Yeah, if I'm out of bounds or this position has already been simulated, then return. Otherwise, we add this position to have been simulated. And we need to actually here switch map at position. Case it's a period, then I continue like before. Case it's a minus. Or should I do different switches? Because there's gonna now be quite a bit of branching. Well, let's see how ugly this becomes, and then I think I might want to do this if branch outside this switch. So if our direction, or if our direction is left right, then we pass as if it's just nothing. Else no, missing this one. So if it's a top-down direction, then we recurse. Simulate position -1 direction -1, mask left, right. Simulate position +1, direction is +1, left, right. Oh, actually, let me do a tail call optimization here immediately. Pause, plus pause, direction equals 1, mask equals left, right. So I'm not going to call back here, but what I'm going to do is just continue in this same function. Case. Yeah, there's gonna be quite a bit of these cases. Maybe this can be simpler somehow. Let's go here. Case vertical pipe. Yeah, no, I need to replace this with. Okay, let's do this. I need to do these integer values because my encoding is not quite working, so let me do this. Map I. So what I'm going to do is I'm going to print out the values from this map, so I can work on whatever broken encoding I have. What? Okay, so backslash is 92, /47. Okay, that I think / will work. -2 should also work, 45. Pipe 125. Is that everything in it? / / -pipe. Yeah, that should be it. Okay, so now we've got those values. So wait, here's my switch case. So I'll come here. Case case pipe. So that's 125. I think it should be, if I remember correctly, it should be 0 by DD. Is that what this is? Well, I'll just use an integer. So if mask is up down, position plus equals direction break, else actually this break here is not necessary. Just go like this. Yeah. else we recur. Simulate position minus stride up down. And then I'm gonna continue simulating the vertical direction. Position plus equals stride, direction equals stride, and mask is up. Okay. Okay, so that's 2 out of 4, and then the mirrors. Case forward slash. If mask equals up down. If mask equals up down, so we must. Oh, but I need to look at all the 4 directions. Actually, let's just do it from if direction equals 1, I'm going to the right. Then actually I'm going to be mirroring to go upwards. And then position minus equals. Actually, should I do? I'm doing this position equals 0, position equals 0. So actually, I can just do the position equals direction outside. Position equals direction here. So these things don't need to independently update all of this stuff. Yeah, that's gonna be a great simplification. No need to update position at all. And this is actually just going to be a single liner. Else if direction equals -1, right? Direction equals down. So we're going left, now we will mirror to go down. Yep. Equals stride direction. So we were going down. We will now have to go left. Else direction must equal right. Okay. Well, that wasn't too complex after all. And then the backslash, the pound symbol. So that's going to be this thing repeated again. But this time with backslash, so 92. So if we were going to the right, now we go down. If we're going to the left, we go up. And I guess if we're going to the going down, we have to go right. Okay, so this nicely mirrors. Okay, and that should be everything. That should be hopefully everything. So let's see this logic overall. I simulate in an infinite loop if there's nothing in this map position, then we're done. We've fallen out of the edge. Or if we've already simulated this ray at this position. Mark the ray at this position to have been simulated. and look at what's underneath this character. Oh, no, now updating positions here. So this is redundant. So minus, if we're splitting, simulate going to the left, and we will continue right in this function. Perfect. If it's a pipe, if we have left-right direction going, so we simulate, we recurse to simulate upwards. And we continue simulating downwards ourselves, yeah. And then on the forward slash we do the 4 mirrorings. And likewise on backslash. Perfect, okay. And then at the end, my friend, we do for int y equals 1, y is more than equal to height plus y, for int x equals 1, x is more equal to width plus x. So I'm traversing one off because of the sentinels. And then I have u16 lit squares are 0, lit plus equals light y shifted left 7, or x. Yeah. Print f. Lit squares. But where's the simulation? I lost the simulation line. So simulate at position 0, so s plus 1 in our sentinel world. Direction to the right and left right kind of movement. And we should be getting the answer of 46 when we run this. No, we got a crash. And a really interesting one at that. Yikes. Okay. Why would that crash? Nine. Why would that crash? All looked so good. Well, can I... Okay, I really do not want to do... Define stride equals 40. Voila... Oh, 40. Volatile star map equals star 0xcc00 plus stride plus 1. Oh, no, not for this one. This is just this. And I forget what is star light equals U8. U8 light equals. Just give me a second. I think it might have been D800, but just give me a second. Yeah, D800. Cannot initialize a variable. Okay, yeah. Volatile. Star. Star. Okay. And then in here, let me do a catch. So what I'm doing now, I want to just to draw this on the C64 screen as this is executing. That's gonna be my debug. Run. Okay. Oh, wait. Yeah, no. Yeah, it's working. Okay, so the white light is going. Yeah, it's hitting a splitter. Should go to the left. And then to the right. No. It took a really long time for it to go left, but it did. This square is 2804. No, it didn't crash. Oh, but actually, when I run this, the fact that I print anything, that actually disturbs. This thing. Okay, let me do actually this kind of thing. Oh, that's a logical OR, not a binary OR. Oh crap, I do need to fix my... Okay, hold on. I need to revert my change to get that pipe working. Maybe like this. Oh no, this got stuck in saving. So now I'm again having this bug. I have a guess where this bug is coming from, and this starts to happen when the disk is getting full. Like I had a couple of good days without that crash at all. And now I think my disk is quite full, so I'm getting this issue again. So let's see, log from 2023, 16A, 350. Okay, so here, let's see if this works. No, it doesn't work correctly still. What does this serialize do? It takes it to a back to a closing curly brace. Extraneous closing brace. Okay, now I think I see the issue. Yeah, okay, now I have the OR. Now I have the actual binary OR, so... did I use OR somewhere else? Here. OR. Okay, now please don't crash on me. Please don't crash on me. Okay, so this computation of the lit squares was wrong because of this OR. but now so the thing that I broke in this ore handling is that basically in Petsky the topmost bit should be this reverse bit, and pipe is a 0DD or a 07D. So I was confused why my pipe were getting this DD, and I was expecting it to get 7D. So that was where I got. Oh, Temporalix. Hey, how is it going? Back for more Advent of Code? Yes, yes. Did you solve today's puzzle yet? Yeah, I'm still debugging mine. Ooh, and now I'm not getting... No, I'm not getting... Yeah, alright, good one. So, this one... I'm doing some visual debugging now on the C64 screen. Light pos or equals mask. So hopefully I should be pretty close to done with first part, but for some reason my simulation is not quite going the way I want it to. So let's see what happens. Yeah, I'm expecting to visually get this. Let's see what this says. Oh, not that one, but this one. Four, 5, 7, 6. How can I get... Oh, actually, no. And 3, and I do need to mem set before I simulate. Okay, yeah, now that I'm debugging this. Mem set light 0 1000. And let's go for Char Star. Yeah, I had to check through a lot of different paths to figure out some bugs in my code. Yeah, it's easy to sneak in a couple of those in this one. Lit square is 43. Okay, so now I'm getting closer. Now this is... So let's see where am I missing. Yeah, I got a secret weapon. I got the screen RAM for C64. So I can do this. Here's my light going. Okay, it's hitting a splitter. And then it's doing something weird. I'm not quite sure. That's not healthy. That's... Oh, it's going through, okay. So... Oh, here, actually. Before I start, I need to check. If not, map. So if I'm in a sentinel square, I have to immediately return. Okay, so now the light comes over there, goes down, hits to the left, and now this should be safe. No, it's still going. Oh, it's going through the map, and then it's going all the way over there. Yeah, that's not maybe correct. Maybe not correct. Let me mem set char star map 0 1000 before I start any of this. So this should be... The logic should be good, but some reason... Wait, what is this and here? Or... Gee, what a bug. Okay, and this is no longer needed. Okay. Now let's see what happens. Come on, now light, you travel fast. Okay, goes here, splitter left. No! It's still traveling through... Wait. I don't know where it went, but it didn't come through this whole thing. Okay, so... Wait, and then it traveled through... So here... It's split. Okay, this one goes here, 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 here. But now I think I have a bug that it walks through the splitter. Yep. So I have a minus, it goes through the splitter. Split squares 52, so minus... This one goes through the splitter. How is that possible? How is that possible? If mask is up, down, so I'm coming from like up or down direction. Simulate position, we go left. Direction is -1 to the left, left, right. Direction goes +1. And mask is left, right. This is a horizon. Had to rewrite my splitter code like 5 times. I kept mixing up my lefts and rights. Yeah, I have also some kind of insidious bug here. Actually, let's do this. Case. If it's a period, we do nothing. And then default printf. Oops. Not efficient. Like, do I have some of this stuff going on in here? Oops, 32. Oh, that's a result. That's a result of me going to the screen RAM to debug, I think. Let's go for this. But I do need to do U8. Okay. Now let's see. Why? Go right through the splitter. And it didn't even recurse. Minus. Aren't you going... Minus. Up, down, to left, right. Something like that. Come on, go light. Minus, up, down, to left, right. That's exactly minus. Oh yeah, in those two instances, the thing does split properly. Minus, yeah. But it doesn't... Wait. I must have, now I understand. I must have a bug in one of these other cases. Type. Mask is left, right. Direction is up, down. So I'm thinking I'm getting my mask somehow incorrect, but... Oh, of course, here's my bug. I don't update the mask. Shit. So I have two variables. I have like a direction variable and then a bit mask variable. What was I thinking? And actually, it's easy that in all of these cases, the mask flips. So mask G. Mask equals mask. If it was up, down. Mask equals up, down. Then it becomes a left, right mask. Otherwise, it's an up, down mask. And then the same for this stuff. Okay, I think that was my issue. Now I'm confident this works. We go here, yep. Go through. And there, and now you split. No. No, crap, no. It's like this vertical splitter. Didn't split. Vert split. Oh, did I now? No, that couldn't be the case. Vertical split works here. But not here. Wait. What is that character supposed to be? What is that character supposed to be? Oh, that's not a vertical split, that's a backslash. Right. So okay, so this is a backslash that goes down. But I should have red color when I'm going down, and I don't. So it's this one. Wait, do I need to have parentheses here? It's basically this case. Oh, I think I need to have parentheses there, maybe. Okay, now it works, yeah. I was missing parentheses. But now I have this debug print. Okay, finally. Finally, now I'm happy. So now I'm getting... Okay, so now I'm getting, yeah, horizontal. Oh yeah, this looks so good. Lit square is 44. Come on. No, that wasn't the case. It was 46. Why am I missing? I'm missing a full path. It's kind of tough because my characters are all wrong, but let's take a look at that once more. What did I miss? So this is a vertical pipe. You go down. And this is a minus horizontal pipe. You go left and then you go right. Through the splitter, go up. Then you go right. Right, and now you have to go down. This is a backslash. Go down to the splitter, then you go left. And this is a vertical split, so you go down. And yeah, you don't have to go up because that's already computed. So you come back. You go right here, yeah. That's a vertical splitter, so you go up. Also up. And this one goes to the right. But it didn't. No, it goes to the left. And oh, my logic is wrong. Oh, yeah. Now I see. Now I see. I need to... Oh, nice. Okay, so... I just used 2 bits. Where I've been... like left, right, up, down. But that's not the case. I need to use 4 bits because I can, with this kind of backslash as a forward slash, I can enter from 4 directions. But maybe I could I? Can I somehow use the enter and exit directions? Or actually, no. What I'm gonna do is... okay, this is gonna be a little bit of a hack, I think. So first of all, that is needed. Bool visited equals this. That's visited. But then if if I am at a forward slash or a backslash equals forward slash or map position equals, was it 92? Yes. 92 visited equals false. So I can just opt to not track the visited boolean. For the like the mirrors, and then if visited return. So this is gonna simplify. Oh, what just happened? Yeah, so now it's going through all the places. 52. Why do I get 52 then? I am somehow... Now I'm tracing the right path, but I'm somehow calculating the wrong thing. Oh. And 3, not 0. Okay, and now let's get rid of this sketch. Give it a run. 21. Let me put back this thing. So I'll take, I don't visualize this anymore in the graphics RAM. 46. Okay, so that was something to do with the graphics RAM. 46. Yeah, that's okay. So now I get the right answer on this example. Now I get a right answer. So this one and this one shouldn't be needed, right? Yeah, 46. Okay, so now I'm ready to go to the actual input. Let's see how this looks. Let's see how this goes. And this, the complexity should be well within a linear complexity. Okay, so now it loaded the map. Oh, that was super fast. 7472. The map size was like 100 by 100 or 110 by 110. So this looks like a fairly decent number. 7472. So let's try to submit that. 7472. Day 16. Seven, 4, 7, 2. Yep. Oh, cool. Okay, first part done. That was a lot of work. Why did it take that so long? I had one logic mistake or two logic mistakes in the simulation. Yeah, that was mainly it. And then a couple of crashes, but those were okay. So what is the second part? What is the second part? I'm kind of afraid this is going to be something really computationally intensive. Let's see. So I'm going to put it here. And then print. Okay, well that wasn't too much text. Okay, I'll just click here. How many tiles are energized in that configuration is the question, but what do we do here? What do we do here? It's only one page. Okay. As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There, a collection of buttons lets you align the contraption so that the beam enters from any edge tile and heading away from that edge. You can choose either of two directions for the beam if it starts on a corner. For instance, if the beam starts in the bottom right corner, it can start heading either left or upward. So, The beam could start on any tile in the top row heading downward, any tile in the bottom row heading upward, any tile in the leftmost column heading right, or any tile in the rightmost column heading left. To produce lava, you need to find the configuration that energizes as many tiles as possible. In the above example, this can be achieved by starting the beam in the fourth tile from the left in the top row. So here, I guess, 51 tiles. Okay. Well, I mean, the C64 was pretty quick, right? It was pretty quick. So I'm thinking, yeah, why not? Actually, yeah, and I'm thinking, is there a smarter way? There's some kind of like equivalence class mechanism at play. But not quite because of the splitters. 2023 16B CPP. Not because of the splitters. Oh, I didn't save this. Okay. So I lost this part. And this one. All of this other stuff should be, yeah. Memset go away, volatile go away. It was pretty quick to simulate this, so yeah, why not? For so I'll have U16 max lit equals 0. For int y equals 1, y is smaller than height, plus y. So let's do U16 sim score. U16 post int direction U8 mask. And in this function we will simulate and score. Right. And then return lit. But we also need to do here memset light 0 size of light. Yeah, I might need to now optimize. I'm using, like, I'm wasting 6 bits out of each of these. Oh, actually, I don't need this one. I'm wasting 6 bits, so that would speed this thing up. 4. Oh, actually, yeah. Max lit is max of max lit, and then simulate. Position equals y plus 1 times stride plus s. Direction equals right, left, right. And then coming left, it is simulate y plus 1 times s plus 1 plus width minus 1. Coming left, left, right. No matching function call. No matching function call. What? Kinda confused. Kinda confused. Is it not liking something in this expression? Oh, not. Oh, crap. Now I understand. I was calling the wrong function. Synth core. Okay. Yeah. Perfect. Okay. Let's save. Oh, actually, this one needs to be equals. Oh, I already account for, yeah, like this. Now it looks good. And then the same for weight. X equal 1, x is smaller than width, plus x, max lit equals x plus 1 plus s. X plus s. Going down. And then ooh, what is this? H times s plus x minus s. Oh, I'm so going to make a mistake with this this indexing, right? Max lit. Am I? So S accounts for the sentinel row, and this accounts for the sentinel column. So this should be right. And here the last row would be h minus 1 without sentinels, but then plus 1 for the sentinel, so that's h times s. accounts for sentinels and the map size, and then this accounts for the sentinel column. Hopefully. Let's see what this gives. Well, I should probably add some kind of print. How long does this take otherwise? This does 75. 51, crap. Okay, that's not right. Oh, no. Yeah, 51 should be the answer. Why am I getting... So this would be just y times s plus width. Y is 1, y smaller than height, plus y. Oh my god. Oh my god, what am I doing? What am I doing? Post direction mask. Oh, now I actually understand. I should score while I simulate. Like, yeah, let's do that optimization. Actually, let's not yet, but yeah, I need to remove this loop. This is really slow. So I should be scoring the thing while I am simulating. But before I do that, but I still think I have some other issue. Because I think, didn't I get a bigger score than the maximum? Lit squares 90. Yeah, I'm lighting everything up. Let's debug actually these values. So I'll do this. And let's take these. Here. And then this one. Like this. Oh, not like this. Yeah, so this might give me a little bit of a clue. H times S plus X minus S UD. Two. And then this one. Okay. Okay. Oh, did I still have... Oh, I had this. Not 0. I had that bug. That I didn't save. Or that got lost in that crash when saving didn't work. Okay. So 51 should be the maximum. 51, x equals 4. Yep. That is the correct one. Okay. So I think I'll just take this to the whole thing. It's gonna take a while, but I think it will spit out the answer for me. Actually, before I do that, well, yeah, let's wait. Let's wait for the disk access. I think if I abort the execution in the middle of disk access, then that might not work that well, but let me... I need to add one more thing to the code. Oh no, it crashed. Okay. What was that? Like 5 seconds per thing. Five seconds per thing, so that's... half an hour. Half an hour of computation. Well, if the C64 can do it in half an hour, I think that's pretty impressive. But yeah, I'm thinking... So something that makes this really slow is that I need to do this 16 kilobyte mem set here. I could reduce that by a factor of 4. But yeah, what I wanted to do here is add a bench. Bench statement. Let's add this one also. Well, yeah, let's run on the example for testing. Oh, what am I printing? Twelve and a half seconds, yeah. Not here, but here. This y equals okay. let's go for the actual input. This is gonna be a massive computation. So if there weren't any splitters, then you could just leave the results of the computation as is. And like wherever that beam goes. An immediate crash. Wow. Monitor. Address A79A. That's a weird address for the code to be at. Do I get a call stack? I can disassemble in there, but yeah. Okay. Why would I be crashing? There, but not on the small input. 92316 BCP. Why would I crash there but not on the small input? Let me do this scoring. Actually, I want to do this scoring. It's bugging me. Score equals 0. Here. If not light position. Plus 4. Score equals 0. And return score. Bench. Why would this ever crash? And where did it actually crash? This does seem right. $51, 11.8 seconds. So seems pretty good. But on the actual input, that's not. That's not enough. But the fact that this gets only 20 from the other direction, that doesn't seem. That feels so weird. Oh, and did this hang now? It didn't. That's interesting. That's super interesting. Okay. Yeah, I think this is now all crashed. Yikes. Okay. Y equals 2 crashes. This should be all safe and valid. Oh, I don't necessarily need to do this difficult, because I could do like define at xy to be u16 1 plus 1 shifted left by 7 or forward by x plus 1. Right? Oh. Well, that should give me the thing with the sentinels. And then I could do here y from 0 to h plus I, and then at 0 y, and then at x minus 1 y. Not x minus 1, but width minus 1 y. And here I would be at x 0, and here I would be at x height minus 1. Oh, and need to fix that for loop. For loop for x. So this would be like this. Yeah, I think this should make sense. And it does properly compute the example. Let's do that for good measure and give it one more go. Yeah. Very weird indeed. And it crashes again. Oh, do I maybe... Could I be recursing too much and I blow the call stack? I'm recursing back to the simulation call. Yeah, maybe that might be it. I mean, I did use pretty deep recursion in previous days, but... Yeah, let's have that as a hypothesis. So the idea being that there are so many splitters. There are so many splitters that calling back these into these simulation functions in here, it's too much. So let's do stack. Do we still have space for a 1000 element stack? U16 pos in direction U8 mask 16 stack size equals 0. Stack SS or yeah, SS plus plus equals position direction mask while SS minus minus. Where are my returns? They are at here, so that's nice. They're at the top level. Break. Pos equals stack SS pos direction equals stack SS direction and mask equals stack SS mask. And here I need to NQ. Stack SS plus plus equals pos minus 1 left right. And here stack SS plus plus equals pos minus S minus S. Okay, that's the guess. I think that's the best I can kind of figure out. That yeah, too much recursion. And that then blew up. This would probably go to the one-page stack. I'd imagine. I'm not quite sure. Like, some of this stuff goes to the one-page stack, and some of them goes to the LLVM stack, but I'm not quite sure, like, to distinguish which goes where. But in this case, how large can I make this? Not that large. Not that large either. That's okay. Okay. If oh, no, come back. If S is greater than 105, So now we should see, and here the stack size should always be 0 because we've unwound it. Or actually no, actually well, let's do this. Okay. Let's see what happens. Okay, we're on the example. Well, okay, that didn't quite work out. I get all sorts of garbage on the screen. And then a crash. Okay, I think I've taken the... No, what's happening? Why would I get the screen full of garbage? Like, what? The only thing that I did there, I'm taking the global data section pretty tight to the max size possible. Oh, where did... I didn't save, okay. While ss minus ss if stack greater than 24 okay, so we get this. Oh, not stack, but stack size. And here as well. And then in here, just for good measure. Okay. Okay, so okay, now I don't get that corruption. So I think I was pushing something against the limits. 11.9. Something against the size limits. Which would have then blown up something. But it overflowed to the screen area. Which is kind of weird. Well, let's see what happens with this. Please don't crash on me. Yes. That... Okay. Okay, so it was a call stack overflow in the previous crash. So that was a good guess. It's interesting that a lot of these are really short execution. Like, well, I guess they like run into something and then they immediately bounce out. Okay, so this is gonna take a while. Yeah, I'd love to know actually how would I not have to compute all of these, because there's a lot of like the 7460. So I think they're like in an equivalence class, because like when you enter somewhere and exit somewhere, then if you shine that light from the other direction, you get the same. But then that splitter thing kind of throws a wrench, because that is one directional. So there the enter and exit are not the same. So if it was just mirrors, I would have been able to optimize that. But I mean, that would have only been like divided by 2 optimization on the iteration counts. But here... But I suppose still you could optimize basically by forming like this kind of like connected areas, contiguous or connected areas. So when you do have these sequences that go through only mirrors, they would be like in the same equivalence class or like contiguous class of light going. And then when you split through the beam, you would then have 2 separate classes, one for the pre-split and the other one for when the split has already occurred. Yeah, that could work. So a data structure for that would then look like, for each cell you would have 2 pointers. Pointers to a structure that represents like the equivalence class for horizontal and vertical light in that cell. And then that what that points to the equivalence class would contain the size of that equivalence class. And then potentially, yeah, there would be like interestingly this kind of hierarchy of parent and child. So when you go through a splitter, yeah, that would be kind of interesting. Should I optimize or should I implement that? That would be an interesting one, although this one doesn't take that long. It's gonna take a couple of minutes. Okay, I'm gonna have a short break and I'll come back when this is about to finish. So I'll see you all in a bit. All right, that is it. 11 minutes 6 seconds. So lit squares 7716. 11 minutes 6.0 seconds. 7716. Command A. Let's see. Seven, 716. Yeah. Yes. Woohoo. Okay. That was that was something for the C64, but I think the C64 can calculate this much faster if those paths are stored in a suitable data structure. Then it doesn't need to redo any of those paths that it's already seen. So I was thinking about this equivalence class, but you could basically pre-compute the lengths or like the ends of these kind of runs. But I think that will be something that I might try in the later today or in the evening or something like that. 7716, so 11 minutes and 6 seconds, so yeah. Still, oh. What's going on with this map? There's now tons of pipe characters in the middle. This pipe symbol is just killing me. Okay. But yeah, still all stars with the C64, so that's pretty cool. And I'm pretty happy about today, so that because I was able to fully solve this on the C64, didn't have to do any debugging on the PC. And today wasn't that hard. Like it wasn't a difficult puzzle. Like let's say like theory wise, or like you know, like no like it didn't get mad computationally, but it was pretty nice. Okay, I think this was everything for today. So this was the code. It came down to 118 lines, so not bad overall. And I still had 4.6 kilobytes of memory free for this document, so that was pretty cool. Okay, take care, internet. That was today's puzzle, and I'll see you tomorrow then in the usual time. Bye.